Welcome to lesson 3, problem number 3, where we are going to do a little geometry and integrate it into our algebra work with inequalities. So what we know is that the perimeter of a triangle is greater than 15. So I'm going to put down 15 as the lowest possible perimeter, or it has to be actually a little bit greater than 15. So it could be like 15.01, 100, that is. It has to also be less than 30. So perimeter is found by adding the side lengths. So if the side lengths are in a ratio of 7 to 5 to 3, even if you have no idea what this triangle looks like, I'm just going to make this up. I'm going to make this the 7, make this the 5, make this the 3. Doesn't mean that the sides are 7 to 5 to 3. It just means that they're in a ratio of 7 to 5 to 3, which means we can put an x with each side. And if x takes on any value, we would still have side lengths in a ratio of 7 to 5 to 3. So what we're going to do for perimeter is we're going to add 3x, 5x, and 7x, which is going to give us a total of 15x. So I'm going to say 15x has to be greater than 15, but 15x is less than 30. Divide everything by 15 to get x alone. And just like that, we get that 1 is less than x, which is less than 2. So now what we have to do is we have to figure out the possible side lengths of the longest side. So the longest side is going to be the 7x. So the value of the longest side, I'm going to kind of write that now in the middle. The longest side length has to be greater than and less than something. It has to be greater than 7 because the lowest value x can take on is just slightly above 1, which means that the longest side length has to be slightly above 7. The highest value that x can take on would be right above, it could be really close to 2, but not quite 2. So that would mean that the largest side length would be, or the longest possible length for the longest side would be 14. So the longest side length is somewhere between 7 and 14, not including 7 and not including 14. Great job.